Alright, welcome to our last video of Unit 8. This one's talking about bond enthalpies. So, as we're studying bonds, we're actually able to go back to thermodynamics and estimate the enthalpy of a reaction based on the bonds that were actually broken or formed within that reaction. It deals with giving charts of how much energy is required to make or break a bond, and then we can get an idea of, well, these bonds were broken, these were formed. Here's kind of overall the net change that probably happened. Energy is absorbed or required whenever bonds are formed, and energy is released whenever bonds are broken. So to form a bond, you need energy. Whenever you break it, that energy is released. The process of estimating enthalpies relies on thinking of reactions happening in two steps. The first is that bonds are broken in the reactants if they're not going to be present in the products. So the very first thing is we break apart basically some of our reactants. That means that the overall enthalpy of our system has to increase if we're going to be breaking those bonds. So, because keep in mind, as we break them, energy is released into the system, thus we start rising our energy. Our second step, though, is bonds are formed in the products that weren't present in reactants. Basically, we break apart the reactants and then re-scramble things to form our products. The enthalpy of our system thus decreases as we use up the energy from step 1 to form these new bonds. So we release energy to break apart the reactants, and then we use up that energy to form our products. The enthalpy of our reaction, therefore, can be estimated as the sum of the bonds broken minus the sum of the bonds formed. So it's basically however much energy was released minus however much energy we had to end up still using. That is kind of an estimation for our enthalpy of our reaction. Now, as you're doing this, you can only solve these problems if you're given a chart with actual numerical data. For example, in your examples coming up, I'm using my book with a chart of numbers to get those. When you're solving these on either AP exams or homework, whatever, they'll give you the numbers there. So, with that, let's work on our examples. So, we're going to estimate the enthalpy change for the following reaction using bond enthalpies. Now, to be honest, these problems can be annoying, and they may not be. What's annoying about them is we have to start by doing Lewis structures, because we got to figure out what bonds actually exist. So, take a bit, make the Lewis structures of all of these, and kind of try to write them as an equation. Come on back and I'll show you what they are. Okay, so here are the Lewis structures of our compounds. I put them in parentheses just to kind of help make it clear, and I put the coefficients next to them. That's going to come in handy. Alright, now what I'm going to do is actually calculate all the bonds that are in each of these molecules. I'm going to take the amount of bonds and multiply it by their coefficients. Well, let me start with counting the bonds. First off, you may have actually put a single bond and a triple here. Keep in mind they're the same atom. They have the same electronegativity, so there's actually going to be two double bonds. But yes, that would change your answer. So in this molecule, we have 1, 2, 3, 4, 5, 6 CH bonds. And I actually forgot our CC bond in here. Here we have a double bond between two oxygen. Here we have two carbon double bond to oxygens. And notice I didn't write the valence electron atoms. I didn't really care, I just need the bonds. Like I said, you should be able to do that in your head, or at least get pretty close. And we have two OH bonds. Now, here's the thing. We ultimately have bonds broken minus bonds formed. So what we got to do is see if there are any actual bonds in the reactants that don't exist in the products. Well, all of them. Okay, that was easy. That means that we have to break all these bonds and then form all of these bonds. Now, before we start doing calculations, we need one last thing, because we got to factor in these coefficients, which means that these are actually how many bonds we have. So what we're going to do is we're actually going to basically do this. Now, keep in mind, I told you there's actually a table with numbers on these. And if you have those, you just plug in the values. I'm just going to calculate and show you your final answer, but keep in mind, I'm using a table. You'll be given that, it's in your book, etc. But we basically are breaking 12 CH bonds, and 2 CC bonds, and 7 double O bonds. And then we're forming 8 C double O bonds and 12 OH bonds. So if this ends up being positive, that says we released more energy from this. If it's negative, we used up more energy in our products. So, final answer comes out to negative 2,213 kilojoules. Again, I just took the values, plugged them in. That's your enthalpy. I looked at our next example. We're actually not going to do it. It really is just super boring and doesn't require like any thought. So I'm just going to leave you with this. Ask me questions if you have, but that actually finishes Unit 8. Thanks for watching, and yeah.